So, continuing our tractability journey, recap. Some problems are intractable on computers, which means that as the size of the problems increases, the number of operations needed to solve, fully optimize, increases as a factorial or an exponential function. And that means that even relatively small increases in the size of the problem cause big problems. We saw that. But we can normally get around it, or often get around it, with just choosing something which isn't quite optimal, but typically is quite close. And there's quite a lot of maths around, how close you are. And in different algorithms, they say, oh, we're 2% within optimal, or 1% or whatever. So it's not that we're despairing about this. Just if we want the perfect solution, we can't always get it. So it's not just a traveling salesman problem. There's also bin packing and stock cutting and a whole bunch of others. In fact, if you go onto the Computer Science Field Guide, you'll find this list. So some reading, Wikipedia-ish kind of reading on those topics. If you want to do those, you don't have to, but it's kind of interesting. They do go into bin packing a little bit, and there's a couple of other related ones. So just go talk about bin packing. So basically we've got some empty bins over here, and we've got some things to put in the bins, and we need to optimize in the sense of we've got as little free space as possible left in the bins by the time we fill these up. But we're always going to have a bit of free space. So if I put that one there, well, it looks like I need one of these shorter ones to go in and there. And I don't think either of these, no, because it says 15 left and I've got 16 on this one. There's nothing left to fit in that one, so then I have to fill up another one with the next one. That's pretty good. And this one can go, oops, that one can go into there. How many's left? 21. I can fit the 17 into there. I need another bin. And that one can go in there. Need another bin. Am I going to be able to fit everything in? Need one more bin. So that clearly isn't the optimal solution. I reckon you could do a little bit better than that. But finding that optimal one is a tractability issue. So there's also a stock cutting problem, which is pretty much identical. It's like if you've got, say, a whole bunch of 5-meter lengths and you want to chop some certain amounts. Yeah, if you're making a deck, for instance, all the wood comes in certain lengths, but you need shorter lengths, and you've got to cut them out of the long lengths. It's pretty much the same as the problem we just saw. And the knapsack problem, very closely related. It's just fitting things into other things, into knapsacks, bags. Also, there's factoring. Factoring very large numbers is hard, and we do mean properly large, not like a few hundred or a few thousand, but like lots and lots of digits. And we'll come into why that is useful in the next video, where we look at applications and implications.